Testing. All right. Uh, all right. Who be here? All right. I still have not revealed what I'm doing yet. Um, I'm gonna wait till a couple of people show up, and then I will change the stream title to what I'm doing. I'll give it a couple minutes. How you guys doing? How you like my just washed quarantine hair? It's been like 11 months since I had a haircut. I'm gonna try to go a whole year before I shave the hair off again. It's getting a little bit unruly. I have shaved a bunch of times since. Like this is only like a 1 month beard. Um, yeah, it's all wet, so it's not like super poofy right now, but it's pretty long. Yeah. All right, 29 viewers. I think in terms of C++ streams, it's probably a good starting point. So you might ask, what am I doing? All right, I'm going to change the stream title. Does my code say nude? Nude D? No, that says mu D or mu directed. That's irrelevant. I just needed something in the background. All right, so you might be asking what I'm doing. I'm going to rank all the reserved C++ keywords in a tier list as of C++ 20. I used this list to make it, and I ignored all of these ones that say TM, TS, or TS because those are uh, experimental and not actually included in C++ yet. Although this one right here looks like it could possibly be getting up there. I don't really have much of an opinion on all the synchronization stuff, but this one right here does look interesting. And it's just the keywords, so it's not these, which are apparently not keywords because I guess you can name a variable final or override, and I don't know why those are not a keyword. Um, and these, which are preprocessor keywords, which are so those are not. I'm just using the ones that are on the reserved words that you can't use for anything. What is reflect expression? It's something to do with reflection. Like it says, which I've not looked into. I didn't even know that they were doing reflection, but I guess it's something like get data map. Like it looks like it's reflection, which is something C++ is needed for a while. Um, but yeah, I'm gonna be referencing these because I'm not. There's at least a couple of keywords that I'm not like insanely familiar with, and there's weird details of there's like weird details of certain things like export or whatever, which has had added functionality in C++ 20 after they removed the functionality. But anyway, yeah. All right, align as but I've used this once. I think I use it exactly once in my engine, and it would probably be in uh, yeah, aligning my matrix so that you can have SSE multiplication work on it properly. It's a very technical thing. Um, It has minor use, but like you're probably not going to be regularly using a line as in your code. But it is like, it's not harmful to use. It has its uses. It's something. It's kind of a weird one, but like there's like it's weird that it's a keyword and not like some other like a pragma or whatever. But sure, a line as goes there. These are not in alphabetical order, which is annoying. Uh, continue. I mean, I use continue pretty often, but every time I use continue, I always feel like um, I should just be like rearranging my code so that I don't have to use continue. Uh, like it's just a go-to in disguise. It's similar to break, but I think break is just a little bit more useful than continue. Um, in general, like breaking out of a loop is something that you want to do pretty often, but like continuing is like, okay, well, yeah, I've done, I mean, I use it pretty often, but like, uh, it always feels wrong when I put a continue in a block of code. Like I could just put if this and then put the rest of the code in a bracket. So I pretty much only use it if I don't want to like indent again. I'll answer questions after I'm done ranking all the keywords. Explicit. Uh, I don't use explicit on like anything. I'm pretty sure that what explicit does is it makes it so that your like conversion operators you have to manually like it won't do an automatic cast on something. Yeah, it's for conversion operators where you have to. Why is this an error in C++20? Yeah, whatever. It's like if you don't want something to be automatically converted to something else, you like continue for returning early from a loop and have less indentation. That's what break is for. Like break is for returning early from a loop. Continue is for continuing the loop. I guess you mean like instead of doing like a function or I don't know. I get what you mean, but like break is more useful than continue. They're both not like terrible keywords, but they are go tos in disguise. Break would be like A tier if you could break out of multiple loops with it, where because that's like something that I do occasionally, and having break not do that is annoying. Explicit is, I mean, I don't really care that much for it. I like my conversions to be automatic. That's like usually the entire reason why I put a conversion. If I want it to be explicit, I would probably rather just use a function that's like named like to another class or something. Yeah, I get what you mean. Mutable. Mutable is going up here with Alinez because it's probably more useful than Alinez. But mutable is sort of just like tells the wait, no, I'm thinking of volatile. Never mind. Mutable is dumb. Mutable is actually probably actively harmful. I'm gonna keep the F tier as the actively harmful one. Mutable is if your class is const, you can still change mutable values within it, which kind of seems like why would you ever want to do that? Why would you want to like defeat the entire purpose of having something be const? It's like mutable would be. Let's see if they have an example. Like, yeah, like mutable would be. Uh, so the values here are mutable, so that. Why did they use such a complicated example that has const in like 5 spots? Like I get volatile. Volatile is useful. Mutable is just weird. Like X would be const, but you could still change N2, but not N. Like it just seems like if you're using mutable, it's not for collections. Like if mutable seems like you want to use const, but you don't want to use const. Like I'll just take like const cast and put it in with mutable because it's kind of the same thing. I don't know. It's one of those ones where like C++ gives you a feature that's somewhat useful and then gives you ways of turning it off if you don't want to use it. So why not just not use the feature in the first place if you want it to be mutable? I don't know. It might have some other uses. There's some shit here that like I don't know like where the fuck mutable. Okay. Removes const qualifications from parameters captured by copy. Just const cast them or whatever. Like, but also don't because this is like just don't make it const in the first place if you don't want it to be const. Public, public's A tier. Like as a keyword, it's whatever. But like things, I pretty much every class that I ever make just starts off with public. I'll get to this more when I go to structed class, but like I'm gonna just have to. I'm not ranking this as the existence of the keyword, but like public in general as a concept. Yeah, public things are good. Switch. Switch is kind of A tier. Like it's definitely not an S tier thing. It might be B tier. It's probably up here because it is again kind of in this like fancy go to strategies. But like what Switch is good for is if you have a lot of things, Switch is way faster than like a big if else chain because it'll jump to the entry that you want, which is very useful in certain circumstances where like is it this? Oh, this file is just literally empty. Um, so if you're like trying to like do a virtual machine kind of thing where you are running a lot of instructions, you don't want to do a big if else chain. So this is just going to jump directly to the case that it is. Yeah, it jumps right to the case. So in terms of like performance, Switch is useful. Like I'm not sure how Rust does it, Pixel Monster, but like um the logic behind the way C and C++ do it, where it has to be like an integer type, is so that it can use a jump table to go directly to the thing that you want, which is a performance thing. Like I don't use Switch if it's not a like Switch is mainly a performance optimization if you have a big chain of if else's. I don't know how Rust does it like performance wise, because I've not looked too much into Rust, but my interpretation is Rust probably does it as like a it's probably smart and does it as a jump if it's like an integer, but the pattern matching part is probably doing an if else chain. All right, using I'm putting it in D. It's not like it might be inactively harmful, but like it actually has some additional uses as of C++20 that I or 17 or something. Um, the fuck is using? So the version for namespace is where you're like using namespace std. I hate that. I don't want to like pull things all into one namespace usually. Using declarations for class members is where you like borrow the constructor of the other class, which I've used in a couple of spots, and it's also just like they also made it be kind of a type def kind of thing. So it has some additional uses because as a C++11, but and C++20, but it's like I don't know. D is kind of just like the generally useless. Like it's kind of redundant with everything. Um, it's actually probably C because it has being able to import a constructor from a base class. I've used it once or twice in my code, but it often feels like there's better ways to do things. So it's a low C. 8-bit signed character, or just the char keyword. I mean, it's a useful data type. It's it's probably a very useful data type, but like I also would prefer if they had a byte data type instead of a char data type. It also, I'm pretty sure this it forces this one to be 8 bits, right? Uh, I don't know if it actually forces it to be 8 bits, but it's 8 bits. It's a very useful basic type. Case. I mean, case is just part of Switch. Like, I don't think there's any place that you use case where you're not using Switch or vice versa. Uh, so yeah, I mean, you have to use case with Switch. Else, I mean, yeah, else is S tier. Like, if else is just it's a classic type which can be most efficiently processed. Yeah, for the care data type. Any weird shit like that is just it can't be S tier because of the weirdness in the C specification where it's like, yeah, it's probably 8 bits on almost everything you're going to use, but like you could use it on a 7-bit Arduino machine or whatever that somebody hacked together in their basement, and then it would be okay for it to be 7 bits. Like, nah. Same with int, but like int is like a good one. Int gets S tier because you're using ints all the time. Else, it's weird to have else without if, so I'm gonna grab if. If is probably like right now. If is like the highest. I use if more than else for sure. Like you can't like you need if statements for programming. It's just how programming works. Private. Nah, I hate private. Yeah, I'm gonna put it in C because like there are some uses for private, but like public, yeah, private, nah. Static cast. I don't know. I prefer C style casts in general. So all these weird ones like static cast and where's reinterpret cast? Like I would rather just use C style casts than these keywords because they don't like why do these exist when you can use C style casts? Like they don't do anything different than C style casts other than like I don't even think I don't like do they do is there any difference between those and C style casts? I don't think so. Except for maybe static cast won't do the things reinterpret. All it would be it's like a more limited version of C style casts. On the other hand, dynamic cast actually does have some differences between C style casts and how dynamic cast works. So I will put dynamic cast in B tier. I don't use it, but because it has like a purpose to exist over static and reinterpret cast, it gets B tier for that. An early version of my engine used dynamic cast to try and like if you wanted to find all objects of a specific type, it would dynamic cast every single game object to the type and see what actually returns non null. My engine doesn't do that anymore because that's not very efficient. Your Java teacher was anal about using the lowest possible access modifiers. Yeah, no, it's I'll get to it when I get to struct versus class, but um, I hate like encapsulation junk. It's really fucking annoying. I don't like. I get it for certain situations. If you're like making a public interface for like if you're writing code for somebody else to use as like an open source thing, then yeah, you probably shouldn't expose too much stuff in public or whatever. But like if you're just writing your own code, like just make everything public because it'll end up it's easier to just have that than to have to write an accessor for like everything. Creating a well-defined API is great. Okay, so I'm going to point out when I get to struct and class, or actually, you probably should have talked about it when I'm talking about private and public. In C++, these are not enforced at runtime in any way. These are only compile time things. In C sharp, at least, they are actually enforced at runtime. So there is a reason to have, like, there is security reasons why you'd want things to be private. But C++, like, you can literally, like, you can just if you had like a code that had a public variable and then a private variable, you can access that private variable with some pointer bullshit, and it's fine. Uh, Union. Union unions are kind of shitty. I use them sometimes, but like there's a lot of issues with unions that are kind of annoying, and it doesn't really work that well with the rest of the language if you have like constructors and stuff. Um, like having a standard string in a union kind of doesn't really work because that string needs its destructor to be called when the union is destroyed, so it just kind of doesn't let you. So I don't like. Well, okay, I'll point out union is here. Like it's not bad to use. It's probably higher up than explicit. It's not harmful to use unions. In closures code base, there was a line of code that said define union struct, which made all unions in a certain header file be structs instead. And that was because Apple wouldn't like had a fucking bug in their own header that was due to a union, and I just turned it into a struct to fix it because I wasn't actually using it. You like to use unions for color structs? How so? Like if you're trying to have a RGB and an RGBA on the same thing or something, or union-based type punning in C++ is undefined behavior. I don't think I don't know if it's undefined or not. Either way, unions are weird. I prefer not to use them if I can avoid it. I do use them occasionally, but like for most cases, you could just use a struct instead of a union, and the only downside would be that you're using more memory. And computers kind of have a lot of memory right now, so I'm not too worried about memory. RGBA uint32, so you have a color struct that's both uint and float at like the same time or something, I guess. I don't know. I don't get why you would use that for color. I specifically have an integer color class and a float color class just as separate things that can be converted between each other. Const init. I don't know what const init is. Uh, I know what const expression is. Const init asserts that it's something is initialized to 0. So, uh, you think all major compilers do the right thing with using union to reinterpret bits, but I've read that it's undefined behavior regardless. Yeah, probably. I mean, you can just use reinterpret cast or a C style cast if you're really trying to do that, which is usually what I do. There was one situation where I had to use a union to cast something because it wouldn't let me cast it another way. I don't remember what. It was a while ago. I was trying to figure it out. Consonant does not. I don't entirely get the point of consonant. I mean, it's a new thing, so I haven't looked into it that much, but uh, can't be used with const expression or const eval. Must have static initialization. I don't know. I don't get it. It sounds like a stupid technical thing that is, like a lot of the more recent C++ keywords are like dumb technical things that are meant to fill in holes that their other things were too dumb to cover themselves. So whatever. Constant goes here. Catch. Um, let's do throw first. Throw. All right. Throw is an F tier keyword. It's like one of those ones where like you shouldn't be using throw in your code, probably. Like exception handling is kind of the wrong way to do errors, in my opinion. Um, Catch, on the other hand, does go up a tier because like you're not gonna get away from other libraries throwing errors if you're coding in C++. So you do have to use catch sometimes, and it is somewhat useful if you're trying to do certain things. But you shouldn't be using throw in the first place. So in your own code, don't like don't use throw. Like there's other ways to do. Like in a language, in a more modern language, like in an interpreted language like C sharp or whatever, or JavaScript, like I could understand throw working better because it would properly like exit, properly destruct things and whatnot, and with garbage collection and whatnot. But it just doesn't work in C++. Like if you throw and you're not careful about exactly how you're throwing stuff, you're just gonna like leak memory and cause a whole bunch of issues whenever you do it. Like my only use case for throw was to crash the program with an error message, but I've switched to just using like I've switched to not throwing at all, and I just pop up an error window, SDL or whatever, and use exit 0, print something to a crash log, and then quit. But no, exceptions just kind of, yeah, just crash. Its nature is exception. Like the only reason why you would ever want to use throw is if you're expecting to be able to recover from an error getting thrown, and that doesn't happen that often in C++. Like what, you allocate memory and you run out of memory. How are you going to recover from that? Like there's no recovering from like a out of memory exception, or like a file couldn't get, like a file not existing on the disk. You could recover from that in certain situations, but like you can check to see if a file exists before loading it, which is like the more correct way to do that. Running out of memory, like if you try to allocate memory and the operating system just doesn't let you, just fucking crash. The computer's on fire at that point. It's like F is the actively harmful, like you are hurting your code by using these keywords. D is the, there's a use for them, but also they're not very useful. Enum. Enum is, I'm gonna put it high B because I use enums a lot. Enum class is better than enum, but like C++ enums still have some issues that prevent them from being like super useful. Um, and one of the main reasons is that there's like no reflection, so you can't like convert an enum to a string or back easily. You have to write code to do that manually. It's kind of just a glorified like list of variables. Um, but I mean, I do use enums a lot. In fact, like I have auto-generated enums in here. Uh, I have like one of my pieces of code is just a fucking like a Python file automatically generates this gigantic enum and then these macros for like kind of reflection stuff. Um, but it is it is like it could be more useful if depending on how this turns out with the update, enumerator list of an enum type, like if this lets you actually like convert stuff within an enum to like the name that it represents, then it's gonna pop up a slot. Long is literally the same thing as int in pretty much every situation that you're going to use it. It's fucking redundant and it's stupid. Oh wait, no, you can use it to make long ints, which is kind of hilarious, but also use int64t instead. Say, but like long double is kind of a useless type in my opinion. Yeah, whatever. It's low C, I guess, because it you some no fuck it. It's high D. My last stream is, it was Hades or Noida, maybe Spelunky. I don't know. I sometimes stream games. I sometimes stream code stuff. All right. Protected. Look, private is in C. Protected is worse than private. Like protected is basically public, but but not. So it's somehow worse than public, and it's like private but not. Like I don't know why you would use. Like, I know why you'd use protected sometimes, but like it was just like pick a side, man. It's like the enlightened centrism of public and private. Like you want to be public and you want to be private, but like you don't really want to decide. You don't want to pick a side, so you don't protect it. Nah, pick a fucking side, man. Stop being stop being indecisive over whether or not your variable is meant to be public or not. Struct. Look, structs S tier. Okay, structs are pretty awesome. Um, like they're like one of the main reasons why you code in a I don't know if I should call it a high level language because it is C++ and C is pretty good. You know, structs existed in C, but structs were worse in C than they are in C++. Like they're it's just a good like you need structs if you're gonna code. Every language needs to have structs, and C++ does them pretty good. They're all pretty flexible and whatnot. Struct basically an object, right? Yeah, it's a collection of data. Uh, in C++, it's exactly the same thing as a class, except for members are public by default instead of private. I'll get to that when I get to class. Actually, let's just do class right now. Class, nah. Class is not S tier. Class is like B tier. And the only reason is because class was added to C++. In fact, class is probably down here. Like class was added to like C++. C only had structs. C++ added classes, but they're exactly the same. It was a completely redundant keyword for them to add. The only difference was that shit's private by default. Yeah, I'll put it next to private, but shit's private by default instead of public by default. And I don't understand why that's the distinction. Like why would they do it that way? Like it's a completely 100% redundant keyword. Although I guess enum class is kind of a thing now, and I don't think enum struct would be, but I have not actually tested that, and it might, it could be. Is would this be a thing? Oh, it kind of looks like enum struct does. No, wait, enum class. I don't know. It might be. It might work. It might not. I'm pretty. I was under the opinion that class and struct were basically identical versus whether or not something was private versus public. Headers being different. No, they're identical. The only difference is whether or not something's private or public. And every time I make a class, which I do use the keyword because I use it as a yeah, if something feels like it should be like it's a class and not like just a piece of data, I use class. But then my first line of code in every class is just public. So like you can see my code if I go to any header file in here, it's you know the first thing I do is public. Well, this is a class. Like somewhere in the define it does class, but you know uh, in every class I make the first. No, there's a structs and classes are the fucking same exact thing. There is no difference between them in C++. Zero. It's a enum struct is a thing. Yeah, see, so it's supposed to be enum class, but because they're the same thing, apparently enum struct also works. It's fucking identical. It's identical to struct. It was pointless for them to add it as a separate keyword. I don't think there's anything that class can do that struct can't, besides you know public or private by default. And maybe that was the point of that was to reduce typing. Like if you're doing OOP, then maybe they expected that you would want stuff to be private by default. But like you have to have something public in a class for it to work, right? Like a class without any public members or variables is actually useless. So um like it's actually useless to have a class that doesn't have anything public. So you could it would be the same amount of typing to have a struct or if like have a struct where you put the public stuff at the top and then you do private and do the private stuff at the bottom. And in my opinion, that's probably more readable than what they want you to do with the class, which is put the private stuff at the top and then do public, and then have the public stuff underneath it. Like it would make more sense to just it would make more sense. Like, okay, struct blah, and then you do like int x and then private, or like int get x. You know what I mean, right? Like get x and then private like int x. Like this right here. Let's just get it away from my actual code. This right here would be, you see your public interface, and then at the bottom there's all the private stuff that would feed that. Whereas like if for a class, they want you to do they want you to like reverse it, where they want you to do public down here. At least if the logic behind having it private by default is to if the logic behind having it private by default was to reduce the typing, like these are your two options here. And in my opinion, having all of your interface stuff at the top is more like cleaner and like a better way to do it than like this right here. So I use class all the time, but it really is a redundant keyword, and the change that it made makes it worse than struct by a lot, in my opinion. All right, unsigned. I do not like unsigned data types at all. I feel like they should have like byte 2 and byte 4 instead of like unsigned char or whatever. Like I get the point of it is that, but like I don't like unsigned data types at all, because I feel like it makes sense for maybe like a short or a char. So it's probably not D tier. It makes sense for like unsigned char and unsigned short. But for ints, which seem to be the thing that most commonly is unsigned, like why? Like the only reason why you would want something to be unsigned is if you explicitly never want it to be negative. And there's like bugs that come in with that, because sometimes you want to compare something to -1, like to see if it's positive at all, and an unsigned thing is always positive. Like you can't do a for loop in reverse on an unsigned thing, because it will wrap around after 0 instead of hitting -1 and ending. So I just prefer to use a larger int type than to try and make something unsigned to squeeze out some extra space. On the other hand, if something is specifically meant to be like a bit field instead of a an integer type, then sure, I'll make something unsigned in that specific case. But I don't like the word unsigned. Oh, nice. 69 viewers. Okay, co-await. There's some other ones, co-return and co-yield. These are new. These three right here: co-await, co-return, co-yield. I don't have like these would be these are in C++20. I think Visual Studio just added them. So coroutines were very useful in C# and like Unity and stuff. So I do enjoy that they are coming to C++ or in C++. Like co-return, I don't know why they couldn't just have that be return, and I don't know why they couldn't have that be yield, and I don't know why they couldn't have this be await. I don't know why they had to put the co prefix in front of it. So that's going to knock them down a bit of like a tier. They were so paranoid about having, I guess there's like a standard await probably. There might be like, well, there's a standard async. Doesn't, which probably has a function named await. I don't know. I feel like they could have just been like, you know what, we're gonna add these as keywords, and you're gonna change your variables and functions that use those. Also, return's already a keyword, so I don't know why they had like they just added that to keep it consistent with that. But whatever, they're probably going to be pretty useful in the future. Probably going to be more useful than uh, any of this shit right here. Export does literally nothing, right? Like it was intended to do something, but none of the compilers did it, so they got rid of it. But then they added modules in C++20, so export does now have use again with modules. But I haven't played around with modules that much yet, and I don't know exactly how effective they're going to be in getting rid of like header file spam. So I don't know what export's going to do. I'm going to put it in D because it has use now with modules. Modules are probably going to be good, but I just don't have any experience with them. So if you wanted to them to not have the code part, you can always use define. Yeah, I know. I use define a lot. Like define would be an S tier if that was actually a keyword and not a preprocessor thing. But export is gonna be, I don't know. Modules are pretty cool. I just haven't used them because I don't know how they work with templates, and I I use templates a lot. Um, but do you have to export the things in? Like, is this optional in a module or not? Is module even a keyword? It's not a keyword. Where the fuck is module? It's apparently a preprocessor thing. Oh, there's no page for it. Okay. Yeah, I don't know. I'm gonna put it in D because I mean it's not harmful. It just doesn't do anything as the template thing, and it's probably gonna be good later. But I don't know. Modules feel like a band-aid anyway. Like they should just not have you not like they should just not require you to have header files. Namespace. I mean, namespace is cool. It's not like exciting, but it does what it's supposed to do. So I guess it's an A tier kind of keyword. Like I put everything on namespace just to avoid name clashes. It doesn't. It's not harmful. It's probably like high B tier, I guess. Like you don't need it. And apparently modules are different. Like it said, what was it? Export. Something was modules were somewhere around there. I saw something that said modules were like tangential to namespaces or whatever. I don't entirely know. I mean, if C code could actually use namespaces, it would be better. So it's namespaces do make it easier to use libraries and stuff. Register. I actually don't entirely know what register does. It does absolutely nothing. Automatic storage duration hints the compiler to place the object in the processor's register, but in C++17, it does absolutely nothing. So nothing. It does nothing. Template S tier. I'm just like some people might disagree. This might be the one where all like the people who there's people out there that insist on using C over C++. Nah, template is like the main reason why C++ is faster than C in general. Which there's a site that actually has a bunch of benchmarks, and that actually surprised me when I saw it that C++ was faster than C on most of the benchmarks they had. And the main reason why is because of templates. Like C doesn't have templates. So if you're trying to write flexible code in C, you have to use like defines to simulate templates, or you have to use a lot of like pointers, which are less efficient than templates at things. C underscore generic. I don't think I really kept up on C past C99, so I don't know what uh, underscore generic would be. I don't know. I feel like using any C features that were not copied over to C++ is kind of dangerous. Um, but whatever. Templates are very good. That's what I'm just saying. Like I use templates all the time. It makes it easier to like templates as you're supposed to use them are S tier on their own. Templates as the fucking pre-process, like the standard library, fucking abuses templates to do things that they're not really supposed to do, but they can do because they're apparently turning like it's a turning complete language by itself, like all the template meta programming stuff. I don't like it, but you can do it, and it doesn't take away from what you like templates in general. Um, no, I'm not a fan of template meta programming. I think that they like at the point where it feels like a speedrunner glitch of programming. Like it doesn't feel like it's something that you're meant to do with templates. It feels like it was something that uh you that they found out that you could do with templates and then they rolled with it and kept adding shit to support that. Like I don't think that that is I think that they should have added other stuff to handle what template meta programming was being used for. But worst parts the compile times, yeah. But I mean, templates are good. Templates are why C++ is faster than C. Um, like the main reason because C is just like you can do a whole bunch of you can generate stuff at compile time that you wouldn't be able to do at runtime. My engine's fucking full of templates. Uh, like I have they're all over the place. I have in yeah, component boilerplate right here. Like all my components, if I'm trying to like my macro that has component derives from a template. Like if I have like a class in here, like say character says component character, this would normally be like character inherits from component, but instead character inherits from derived component with boilerplate with these things put into it, which is also expanded by another thing. And this is so that I can have self super defined and all this boilerplate defined properly and like a bunch of other shit here. Like I don't know. Like I as ugly as it seems, the fact that I can just do this in my client code where I just write this one line of code component character. Character's a component. All the templates do all their shit in the background. And you don't even have to pay attention to them really. And it just kind of makes like it's one of those things that like it's one of those things that components and macros they let you like make C++ into whatever kind of language you want it to be, which is something that all like it's basically something that's unique to C++ and JavaScript. Like those are the languages that basically let you change the language itself to whatever you want it to be. The only difference being that C++ is fast and JavaScript is not that fast. But yeah, no, I don't really have patience for people who act like templates are bad. No, templates are good. Templates are the only thing that not the only thing, but they're like the main draw in using C++ over C. Because everything else you could kind of do with C, but like templates are like a big thing. This is metaprogramming. So when I say I don't like metaprogramming, it's what I'm saying is I think that they could do it better. But the fact that you can do it is still useful, right? Oh yeah, you're posting my Stack Overflow question that somebody actually answered with like a good thing, like an actually good response to the Stack Overflow question. Yeah, well, it's kind of meta programming, but like yeah, you know what I mean. Like I'm saying that metaprogramming, it's dumb, but it is useful. Like, and I just think that they could do it better. But the fact that you can do it at all is very important. So templates are up here. They're not higher. Okay, I'm gonna move int, because it's not higher. I'm gonna move else down as well because if is more useful than else. Like templates are useless without structs or classes, so they can't really be higher than structs. But yeah, template's good. It's one of the best parts of C++. And the people who don't understand it, the dinosaurs that insist that you shouldn't use templates, I just don't pay attention to them. Like they're wrong. They don't understand what they're talking about. Well, I mean, they understand what they're talking about if it was like still the 90s, but like it's not. It's 2021, and templates are good. You appreciate how seriously I'm taking this tier list. Well, yeah, like the I don't know what the word is, but like part of the reason why I'm doing this is because I just want to rant about C++, what's good and what's bad, and hopefully people will learn stuff about keywords that they didn't know before. Look, other people get to like make their programming lists where they go and talk about how much they hate modern C++. So let me do my thing. Virtual is good. I like polymorphism. It's I don't it has some other uses besides polymorphism that are less like virtual inheritance kind of sucks. I would not recommend doing virtual inheritance ever. Um, if I couldn't use C or C++, what language would I use? Probably C sharp. I don't know about Rust. We'll see. I don't know Rust yet. But yeah, virtual is very good. Like there's no reason why you should be afraid of polymorphism. It's kind of one of the like you can kind of do polymorphism and see if you have like a struct full of function pointers and the like it's just nicer to have stuff be explicit and then there's things you can do with it that like it's one of the draws of having objects in the first place. Um some people don't like virtual like you shouldn't use it for everything, but I mean, you don't have to use it for things that are performance sensitive. So, but I mean, for the like in Visual Studio, calling a virtual function takes like 2 instructions longer than calling a normal function. So it's negligible overhead in calling a virtual function versus a normal one. Char 8T, Char 16T, and Char 32T. Now these are I didn't know that these were keywords because int32, int64 are defined in a header as like type defs. So I don't know why these are keywords and not type defs. And uh, they're very dumb when I actually looked them up. Like they char AT doesn't actually have to be 8 bits. Um, there was something required to be large enough to represent any UTF code unit. Like it's at least 16 bits. It doesn't have to be 16 bits. So it could be 32 bits. But it has 16 like I don't know why this is a keyword and not a type def in types.h or whatever. I never use them, so I'm going to put them down in D tier. They really should not be keywords. They should be type defs. Yeah, like why would you want these versus like int 16t or int 32? But whatever. They're down there. Wchar at least has some useful. They have different aliasing requirements compared to char. Yeah, wchar at least has some use. I also don't know why it's a keyword and not a type def, but I mean I use wchar for like localization and whatnot. Um, yeah, it's probably more useful than Linus. And I like there's a whole category of like operator keywords, and I probably should just add a new tier for those because I don't feel like calling like a I don't feel like calling it F tier. Okay, that didn't. Oh, no, this was F tier. I'm just gonna chuck them in here. Operator aliases, like you write and instead of writing. Is it an and symbol or a double and symbol? Yeah, it's alternative for double and. It's like whatever. Okay, I'm never going to use these versus the operators. I don't entirely know why they exist as like keywords versus just having them be like a compiler flag that or like a IDE thing where like you type the word and it converts it to double and as like a uh, accessibility feature. Yeah, compl is a pretty like it's supposed to be complement, but it is a pretty fucking bad abbreviation for what it's supposed to be. All right, extern somewhat useful. Like it's used to define a global variable. It's used for importing C libraries. You have extern C, extern template. I don't know what is this. Oh, that's part of export, so that's literally not even a consideration anymore. I don't know. I use extern occasionally if I need a global variable, but global variables are kind of not great. Um, so they probably I guess it gets chucked down a bit for that. On the other hand, you do use it to import C headers with extern C or whatever. So it gets some points for that. Yeah, put it there. New. New is like new is A tier, I guess. I like new. I'm not like one of them malloc free freaks or whatever. I like just being able to make it object with new. I'll put delete up there as well, I guess. The fuck is delete? Yeah. New and delete go hand in hand. I use them a lot. It's useful. I use it for like allocating memory and stuff. Um, but new and delete are especially because you can override them. They do tend to be pretty useful operators. I don't override them because I have never actually found the need for manual memory manage or not manual. I've never found the need for to write a custom memory manager in my code base. I know this is something that old school programmers love to do. They always want to like, oh, I want to manage memory myself. But every single time I've tried to use a custom memory manager, it's always been about the same performance as new and delete in the first place, or malloc and free, because I guess their operating system memory allocation is pretty good these days. And the only situation where I would want to use a memory manager would be if I want very explicit cache locality between allocated objects, um, and which, if you're doing it on the operating system, you're probably getting pretty good cache locality with new and delete anyway. If you have a lot of memory on your system, which people do have now. Like people have multiple, like minimum, you're going to have 8 GB on a computer. So you're probably getting good cache locality with new and delete if they have that much memory and you're not using all 8 GB. But I understand why you'd want to use a custom memory manager or a custom allocator if you're on like a console where you want to uh, keep stuff local in a smaller memory footprint. But like as you get more memory on your PC, that becomes less of an issue. So just new and delete all day. Oh, you wonder if John Blow would like this tier list? I could do a version of this. This is what I would think John Blow's opinion would be, which would probably be most of this stuff would be in DNF, and then maybe like you have your if statements up here. You'd have your I don't know. Everything that if can do, you could do with while instead. So, you know, whatever. You could just have while. Uh, but no, like I'm a bit younger than John, so I know I have a opinion on programming that's more about a little bit more modern than these people who are programming in the 80s and 90s have, and I understand the benefits and the cons of a lot of the modern C++ stuff. I know some stuff is good, some stuff is not good. Uh, I mean, even 4 gigabytes of RAM is still a lot of RAM if you're making a game like, uh, and you're not making a AAA game. Like Mu is gigantic right now. It loads every like my engine loads everything into RAM right at the start. Like it just fucking chucks everything in RAM, and I'm still only using like a gig and a half of RAM right now in Mu. Um, but yeah, so okay, this is a good keyword. Uh, I don't really know what to say. It's just something that exists because it has to exist. It's not something I'm particularly like excited about using. It's probably higher than new until elite. Like it has uses. You can do some weird shit with this keyword. Like I have experimented with doing stupid things with this keyword. Like um, if you had a class, it's just if you had a class that had like a function on it, like what did I just type? Where did I fucking type? I typed in Team Explorer somehow. Or let's do a struct. And you can do, like you have a function that says struct do something. Something you can do is, uh, like you can do, like you could put this in a function, and then it would not be illegal to like if you called do something on a null pointer, it would just do nothing instead of actually instead of crashing. I've tested that; it works. I think it probably is undefined behavior because if there's any sort of like vtable virtual function stuff involved, it'll probably break. But you can do weird shit with this keyword in C++ that I don't think that this would actually work in a function that like or in like a C sharp type language. But yeah, I mean, it's a keyword. It's kind of like namespace. You just have to use it to you have to use it for certain things. Getting a reference to yourself is a good it's just something that you just have to do sometimes. I don't know how much there is to say about it. Void. Uh what else does void like void has you can use it to define a function, so you're using void a lot if you're defining a function without a return type. So and then there's void pointers as well. People talk shit about JavaScript being weird. Well, yeah, JavaScript's weird because it does a bunch of shit that you don't expect it to do, like behind the scenes. C++, like that does, if you know what function calls do, like that it literally makes sense that that would work in C++. Like there's nothing weird about that piece of code in C++. It's not doing anything for you behind the scenes. It does exactly what you tell it to do. All right, so the void type, like I don't know, void's a weird one. You use it to define a function with no return value, so it has to be at least B, because you're using it all the time. But I kind of feel like they should have reserved the word function as a keyword long ago, and then you could just use function instead. But void pointers are also kind of useful as like a pointer without a type. So it's probably like an A tier keyword. It also just sounds cool, so I mean, it gets a point for that. But yeah, it's probably high. I mean, it's useful, so it has to be. It's A tier because it's useful, but it's also kind of a. I feel like they should have function as a keyword at this point. Pull it out of the std function library and make it a keyword so that you can actually like treat functions like objects like you can in other languages. False. I mean, false is it's kind of a redundant keyword because it could just be zero and true could just be one. But yeah, it's kind of a redundant keyword, so false and true will get dropped down. But I do use it a lot. Like like I don't know if they're explicitly bools as well, or if they're essentially just type like if they're essentially the same thing as like defining them to be 0 or 1. But bools can convert to integer types just fine. So yeah, like bools can convert to integers this time. So like they could just be defined. They could be like a defined in a header, like certain integer types are. But I mean, I use them because they make things clear what you mean when you say false and true. So they're probably B tier. No except F tier. It's going down there with the throw. Like, it's pointless because no except doesn't do anything unless you put it on everything, right? Like, it should be the other way around. You should explicitly have to tag the functions that can throw things instead of tagging the functions that can't throw things. Because this only does anything if like every single function in your program is tagged as no except. All right, requires. This is part of concepts, I believe. Like, yeah, it's part of C++ concepts. So, or it's concept. Yeah, concept. So these go together. I'm gonna put concepts in C tier. Like concepts are good. I will put I will admit that concepts are good, but they're not like independently good things. Like concepts are only good because of issues with templates and their error messages. Like they're like a band-aid applied to like fix some issues with the compiler's error messages. So they feel very weird in my opinion. I'm gonna move them up because like having better error messages on templates is actually a good thing. Like it's actually a really good thing. It's actually good enough that they probably even get B tier, but they're not. I don't like how they're implemented because they're kind of annoying. Like I feel like they're patching shit onto template when they could do it other ways. They could do it better ways. Yeah, they're not even that much better. And they're kind of annoying to write and you kind of have to do meta programming stuff to do concepts. And I feel like they should just let you write like C++ code. Like concept this, if this is this type, then concept goes good. Like just give me some fucking like actual programming to like write the concepts and the requires instead of having to do meta programming bullshit to like, oh, I have to do a class that has a bool template, meta deduction, blah blah blah. Like I don't. But as long as this stuff is done mostly for C++ standard library headers, and as long as all the standard libraries get updated to handle concepts properly, then hopefully they should be good. But they should just do a better job at template error messages. Thread local. Is this just static but for thread local, or is this for globals or like function static? Oh yeah, it's kind of for globals. I mean, sometimes you need a thread local variable, so it's kind of going in the C tier, which is like the no, nothing wrong with it. You use it sometimes. I mean, it's higher than a Linus. I think you'd probably use it more than that. I use it for No, I don't use it for random number. I had thread local for random number generators in my old like enclosures engine at some point, and I think I remember what was happening was it was because sound effects were done on a separate thread, it would not actually properly random. It would they would always play the same sound effect thing, but I don't know, whatever. Sometimes you need something to be thread local, and it's there. Volatile. Volatile is actually somewhat useful. I don't know if it's B tier, but it's definitely high C tier because it is useful. Like volatile basically says, don't optimize this variable. Like that's how you think of like that's not like literally what it says in in the in the spec, but that's how you use it. Like something can be modified via a thread or another program. So you put volatile on it so that the compiler won't be stupid about optimizing it out. And I use it occasionally when I need something like the end is nigh. I had a block of memory that was specifically for the speedrun auto splitter, and I had to mark it as volatile because otherwise the compiler would be optimizing out writes to it because it wasn't being used anywhere in my code. But an external program, the speedrun auto splitter, needed to hook into the application to read this memory so that they could, generate all their events and stuff based on it. So that's one thing that I've used volatile for, and the other thing is just sometimes, at least before the atomic storage specifier stuff was added into the standard library, I would use it for various threading related things. Like if I knew a variable would be changed on a thread, so I don't want the compiler to optimize it out. But that's roughly what volatile does. It's useful. It's more useful than register, which does actually nothing. It's more useful than mutable, which breaks like things that C++ is supposed to do. ASM, nah. I don't think that you should be writing assembly in C or in C++. It's cool that it exists, but I don't think you should be using it. Because you're gonna make your code not portable. But because it's cool that it exists, it's not an F tier. Like if you're using ASM, you probably have a good reason for using ASM. Isn't it a C leftover? I don't know. There's some situations where you might want to explicitly write assembly code. Like maybe there's an instruction on your computer or gaming console that is not that the compiler doesn't understand. Like maybe you're coding on a gaming console that has an assembly instruction for um I don't know, connecting to the internet or something. It's fully possible that you would have a valid reason to use assembly, but most people are not going to be using it. Like these will actively make your program worse if you use it. This you kind of know that you're doing something weird if you use ASM. So it's whatever. There's reasons for it. Generally speaking, uh, don't you're not going to use it for optimization because the compiler is going to do a better job than you at optimizing your code. Almost always. Decal type. I did not mean to put it in S tier. Decal type is probably up here. Like it's a really weird. It doesn't sound good. It's like the opposite of void. Like it has its uses. Like with template stuff, decal type has its uses, but it sounds so fucking dumb. So it gets knocked down for that. But it is useful. You can use it to get a type out of an expression. Like you don't quite know what like in a template you might not know what a times b is. Like that could be an int or a float, and depending on what a and b are, and you might want to use decal type to deduce that. But like, it has its uses. Um, it's got more uses than most of this stuff right here, so it's up here. Dynamic cast is definitely down lower. Float. I'm gonna put float down. Well, actually, it depends where double is. Where the fuck's double? Double. Double is way better than float. It goes next to int. Like, just use doubles. I don't think you get that much performance out of using floats versus doubles unless you're using simmed instructions, but just use doubles. Float is just like worse double. So it goes down here. It's probably it's there in the care tier. Short is also, well, I'm on it. Where is short? Short is just worse int. In fact, short is probably even like, you have reason to use 8-bit types. You have reason to use 32-bit types. You kind of don't really have reason to use 16-bit types. Like, I would have more like, I would prefer them to have a keyword for a 64-bit type than a 16-bit type. So short's just kind of down here. Also, if I really did want a 16-bit type, I would use int 16t from like the typesetter and not use the word short. Yeah, it's also named poorly. It's also not guaranteed to be 16 bits. It's one of those weird ones where it's like it's at least 16 bits, but it could be like 31 bits or whatever. So I don't know. Not is one of these. Return. Return's useful. Like, you're writing like, return is a function keyword, so you're gonna use it. Like, it's an S tier just because you're using it all over the place. If you're writing functional code, if writing any function, you're gonna use return. Auto. All right. Auto is the highest S tier. Auto is probably the best keyword that they've ever added to the language. And it's not even a hot take. Like, everybody likes auto. Auto is better than the other languages versions of auto. Like, that's why that is that makes it like exceptionally good. Like, auto is something that other languages have, but it's named better. Like in C sharp, I think it's var, like var would be what auto does, where it automatically deduces the type of an expression for you. But and var, like var, it just, that doesn't make sense for what it's doing. Like, but auto does. The word auto is better than the word var. Yeah, if the rest of C++ wasn't so bad, then auto wouldn't be as useful. That's also part of it. But like, auto is also extremely useful because there's parts of C++ that suck that auto just does for you. It makes it not suck. So it improves the bad parts of C++. It's good, and it would be good even without those bad parts. And it's named better than what other languages do. It's a copy from JS. Well, no, it's a copy from var. Like, that's what the other languages, or at least C sharp, var does what auto does. But var is not named right. Var kind of sucks. Auto is not dynamically typing the variable. Auto is still statically typing the variable. It just figures out what the type is based on the first deduction, or like the first expression. So if you do like auto x equals 5, because 5 is an int, auto becomes an int. And at least with like IntelliSense, like, you can hover over auto and you can actually get what the actual type is from hovering over auto. So this is a cat data recommended class just from hovering over auto. Like, it's extremely useful. It's implemented well. It's named better than var because var doesn't really tell you what var. JavaScript var, I think it's different in JavaScript because JavaScript is dynamic types, but in C sharp, var does what auto does. And in my opinion, auto is much clearer than var for what it does. So it fixes bad parts of C++. It's good in general. It makes you have less typing. It has good compiler support. It's better than like the way other languages, it's named better than the way other languages do it. So auto is like top tier, best keyword in C++. Default. Default is all right. Does default have any use besides in switch statements? Oh yeah, it has the explicitly defined function or whatever, which they decided to use default instead of, explicitly defaulted. Yeah, so they used it for something else, but it's like I don't know why they would need a keyword for that. And the only reason why they did is because they already had the keyword default reserved from switch statements. But I'm going to have a hot take here, and I'm going to put a default in F because I want to use the word default as a variable name, and I can't because it's a keyword. And that pisses me off to no end when I'm coding in C++. That's the only reason. I mean it's useful, but it pisses me off that I can't use the word default because it's a reserved keyword. For is S tier. For actually is it's above else and double and int, I think. Uh, for is a weird one because it wasn't like it's kind of weird the syntax of a for loop until they added the ranged base for, which is very cool and something that I like. Yeah, range based for loop, which is something that is very very nice, and it does separate it from while, which is also like an S tier loop. Ranged based for loops do make it better than while, but while is absolutely like a simpler statement to understand. Um, I mean, you're using for while and if are like your bread and butter. I'm gonna put them up here because for while and if are like they're all similar. I mean, for and while can be like interchanged with each other, so they're somewhat redundant. But for has things it can do that, like with the range based for loop, it actually has something that's makes it not interchangeable with while, and while is simpler than for. General useful things, standards of programming kind of stuff. These are just operator aliases. Friend. Um, friend sucks. In fact, it's going right next to protected because it's kind of the same thing as protected, where you know stuff's private, but like you don't really want it to be private, but you don't want to like make it public. Like just fucking pick public or private and don't fucking try and break your shit with protected and friend. Uh null pointer. I'm gonna be a hot take here. Null pointer would be like up here with true and false if they just called it null instead of null pointer. The fact that they explicitly put pointer on the end of it, not for any good reason, but because like they were worried that people might have already had null defined in their own code base, like backwards compatibility bullshit. It makes it annoying to use. Like it's useful, but it's annoying to use. Like it's probably above unsigned. Yeah. Like if they just called it null, it would go up a tier. At least it's not co-null. Yeah. Like I've found cases where I've had to use null pointer to have my code compile just with some because of random shit with templates. But um, all caps null, like they could have just done lowercase null to be what null pointer does. Like that would have been fine in my opinion. In fact, I could probably just type def null to be null pointer, like, and that would probably work just fine. And I probably should just put that in my code. But the fact that I have to type out null pointer makes me not want to use it, which kind of, and I don't really have to use it often because I can just use all caps null from C because that works in its place. So it's like it's one of these things where it's like you should be using this, kind of like static and reinterpret cast actually. So it's good that it's right here, but it's like you should be using this, but we made it annoying to use this. So, you know, ain't great. Signed. Signed is worse than unsigned because shit is signed by default, so it's kind of like actually pointless. But it's like the top of pointless. Like it's almost like register because like everything's signed by default, so why would you ever want to use the word signed? Why is it reserved as a keyword? Except signed care. Is char unsigned by default? I thought char was signed by default. This is default if it's omitted. Oh, char can be signed or unsigned. Oh no, wait. Yeah, whatever. Signed is dumb. I'll put it here just because it's not like harmful to use it, but it is pointless. I don't know. Like it. I do prefer my things to be signed, except for chars, which I prefer to be unsigned. Try. Try is going in. It's part of catch. Where did I put catch? I put catch here. Like you sometimes need to use try and catch. C++ doesn't have finally for that, right? Some languages do try, catch, and finally. Finally is always kind of a weird one. XOR, bit or. All right. Do. What's the point of a do while loop? A do while loop is just a go to, but like disguised. I mean, I use it, so it's not. I use it somewhat often, not like it's probably I use it more often than short, so it's probably a B tier keyword because it does have like sometimes you're trying to do something that's like a do while loop. Like sometimes you wanna generate a random number and check to see if it satisfies a condition, and then regenerate it if it doesn't, and you can use a do while loop for that. But I also use a for loop for that almost just as often with like a break. like because that guarantees it does it once, and then I can break out when the condition's met, and that also gives me like a cap on the number of times the loop will go. But I don't know. I I can't put it higher than C. Like it's just whenever I use a do while loop, it's always like this is the situation where do while is useful, and then like 2 minutes later, I'll be like, oh wait, no, I need to use a for loop here instead. Do while zero in macros. I forgot exactly what the point of that was. Oh, it's so that you have to put a semicolon at the end of the macro for it to work. Like that's kind of dumb. Still, whatever. Do is kind of dumb. Go to. I don't think I have go to in my code base anywhere. I think a lot of things in C++ are disguised go tos, and I don't necessarily think that go to is always wrong to use, but I think it's definitely not S tier. I mean, I could be like, oh yeah, go to is absolutely S tier. No, go to is probably F tier because it is one of those things that is actively harmful in your code base if you're doing anything that relies on like object lifetime or whatever. Um, I think it's actively harmful, and I think that you probably should just use uh, the other things that are available. Um, very, very rarely there might be situations where go to would be the correct thing to do. So it's actually probably going up here with ASM instead. Because like you know if you use go to that you're doing something stupid. Whereas throw C++ tries to get you to use throw, and it makes it like throw is actually probably like the worst one here. Uh, I'm gonna take a very quick bathroom break. I'll be back in like 30 seconds. Throw muted. Okay, there we go. Yeah. All right. I was saying somebody made a comment about deep nested loops for GoTo, um, and uh, what I was saying was that if your loops are like nested by two, what I usually do is I just do like I equals int max or whatever to like have it break out after the end. Um, I think doing a GoTo out of a deep nested loop is still bad form in general. Um, and I think that the correct way to structure that would be to have it be a function with a return. Um, but I understand like there's some situations where you might want to use GoTo. It's just that GoTo is like one of those you will shoot yourself in the foot more often than not if you use it, and there's better ways to structure than GoTo. All right, operator. People should. I'm gonna say operator is like low S tier. Like I think operator is one of the best features of C++. Like operator overloading is what I mean. Um, I think it's one of the best features of C++. I think it gets a bad rap because you can do stupid things with it. In fact, the fact that C++ overrode the bit shift operators to be like stream write and stream read is an incredibly stupid example of operator overloading that should never have made its way into the standard library. It was absolutely a terrible way of doing things and probably probably is like one of the main reasons why other languages don't even bother doing operator overloading. Like though, but it's a really good feature, and if you use it correctly, I just it's a sin that they decided that like the first operator overloading feature that they added to the standard library was to make BitShift make what looks like BitShift be stream write and stream read, which uh, such a terrible decision. It was one of the better options before variadic templates. Well, you could just have a function that says write and read that returns the object itself again. Like it's it's there's like no argument that that is a good thing to do. Like I just it's such a bad design, and it kind of makes it kind of like justifies people's opinions of operator overloading being stupid. But I like operating overloading, and I think that Boost has some overriding the comma operator. Yeah, that's also kind of dumb. Boost is just stupid in general. Like I hate Boost. Boost would be like below F tier if I was ranking shit. If I was ranking something that Boost would go into. But no, operator overloading is definitely an S tier thing. I use it extensively. Like I don't have a lot of things that have operators overloaded, but the things that I do have operators overloaded, I get a lot of use out of, mostly for vector math stuff. Like it just makes things easier for vector math stuff, which for games very useful. For if you're doing business logic, I don't know. I don't think you would. First of all, I don't know why you'd be doing business logic in C++, and then second, it's probably not a good idea to do operators there. But yeah, because it makes vector math so much nicer. It's an S tier, and it also you really miss operator overloading when you're working in a language that doesn't have it. Uh, size of. I mean, this is one of those ones you use it in the case where you have to use it. Um, so it's kind of like a decal type, but it's like I don't use it often, but it's high like it's high C tier. I think one of the things that I can do is like if I'm just curious how large a class is, I can just do that, and then it should. Or does size of require you to do this? I forget. Like, forget the syntax. Oh, it should be in my namespace. I forgot. Like you can just hover over it, like if you just write it in Visual Studio, like you can hover over it and you can see how large the class is, how many bytes it takes up. So that's honestly what I use size of for more than anything, is to just see how large a class is. But I know that you have to use it if you're using malloc or whatever to like grab memory for something, and so it has its uses. Uh, yeah, it's used in define like size of. I have a define for length of, which will tell you how long a static array is, which is just size of the array divided by size of array bracket one. But yeah, type def. Type def's cool. I don't know if it's A tier. I think using kind of has like some overlap with type def now. I'm gonna put it high B tier. Nah, type defs are very useful. It's nice to just alias things. It is weird that you like the order that you have to like you do like the you can't just like if you're trying to type def like int to int 32, it would be type def int int 32, right? It's not type def int 32. So it's like you it's the opposite of define. Yeah, you confuse the order with define, which is it's a fair criticism of it, and it probably chucks it down a bit. And I think that going forward, using is going to end up being more useful. Where did I put using? Did I rank using already? Yeah, going forward, using is probably going to be the more useful version of type def. But since that's a relatively new thing, um, type def is still going to go. I mean, you use type defs. I use them a lot. Like I have a whole file that just like type defs like U32 to unsigned in 32, just so like have nicer types. This is not anything. Let's just get rid of these. That's also one of those. All right, bool. Bool is definitely not as useful as enter double, but it's still, bool. It's a bool. Like it's the fact that it takes eight. Like the fact that the compiler doesn't do anything smart with bools is really annoying. Like a bool should be able to make it a 1-bit thing if it can, but it for whatever reason it always makes it 8 bits, and it's basically indistinguishable from character. Um, in a lot of situations, but I don't know. Bool still it has its uses. You want this as a type in your programming language, so it has to be at least A tier. Does standard vector bool use 1 bit per bool? I didn't I didn't know that. I knew there was something in there that would do it, but like, do I use bit fields in my code? Occasionally. Yeah, standard vector bool, like that's not part of the bool keyword. That would work if it was like just, but like that is the fact. Like bool is just weird, so it's not S tier because it's kind of weird. Const. Um, I generally don't like const, but it's not terrible, so it gets to be in the C tier. Um, in general, I think that the main downside of const in C++ is that it is not enforced properly. Like you can you can mutable and const cast things to get rid of the const, so it doesn't actually have any guarantees that what you're doing is const, and as a result, I'm not entirely sure that the compiler can do anything to optimize stuff that is declared const, because there's ways that it could not be const. So I think it kind of just does nothing. And the only reason why I use it is because sometimes, if you're propagating a const thing through, like if you have a const value somewhere, then you want to make sure that the functions of it work properly with const. It would be higher. It would be an A tier thing if it could actually have like guarantees that it is in fact const. Yeah, it is kind of annoying that it isn't default. Um, at the same time, I think I would be more annoyed having to write non-const everywhere or whatever. But like, I feel like const should have more guarantees that what you're doing is actually const, so that the compiler could actually do stuff with the information given by marking something as const. Like, that's probably my main reason why it's low here, because mutable and constcast exist, so the compiler can't really do anything with the knowledge that something is const. Yeah, it's a lie, and it poisons code bases with const. That said, I still use it because sometimes I want to. It's sometimes useful to have a function tag just like, oh yeah, this is const, or like, const references and const pointers are useful to pass to a function to say that, oh, this is not going to get changed when I pass it to this function. It's a glorified comment in most cases, though. So I'm actually going to move it down just because of the fact that it's a lie and it doesn't actually mean anything. Static. Static is definitely up in B at least. Static is weird because it has so many different meanings. Like, uh, and one of the weird things about it is that like some of the meanings of it are like contradictory. Like, static is used to make a variable, like it's used to make a glorified global variable if you put it in a class, right? So, like in a if a class has like static int counter or whatever to keep track of how many times you've created an instance of this class, that's a glorified global variable. If you do that outside of a class, it makes it a file local variable or function. So, oh yeah, in a if it's inside a function, it's also kind of a glorified global variable, but more than that because uh it'll be different across templates. I'm pretty sure. Like if you have a template class, it'll be different for each different instantiation of that template. So it's more than just a global variable, but it is a fancy global variable. But then if you use static outside of a class, it's a file local variable. Like it will purposely not, like you can have a function that's named, do thing in one file and do thing in another file that are different. If those are not static, the linker will complain because it has two functions that are named the same. But if you put static there, it keeps those functions file local. So I don't know why they use static for that, because it feels to me like that's the exact opposite of what static is used for otherwise, which is to make a glorified global variable. And why in one situation it's a glorified global variable, and in one situation it's a glorified local variable, which are kind of opposites. But I mean, I use static a lot because it is a useful feature and it has a lot of uses. C++ also has anonymous namespaces. Yeah, static is they could call it foo. Like foo would be a better fucking word for static than static, just because it's just, you can't think of a word, just use static again because it's not, it'll parse properly in this situation. Uh But yeah, it definitely it has its uses, so it's B tier. Um, type ID, type ID, and type name was different. Type ID is for C++'s RTTI bullshit, which sucks. Don't use type ID. It's not like actively harmful in the way that mutable constcast are, but like C++'s runtime type information shit is terrible. It basically doesn't work. You're not getting what you expect when you use type ID. Um, you don't know what type ID means? Type ID will get you the name of the class that something is. I don't know if it works with polymorphism because I don't use it that often. It might because it is part of C++'s runtime type information stuff, but it doesn't like get you the name. It gets you the mangled name. So sometimes, like if something is mangled weirdly, you're not going to get the correct name from it. Dynamic casts and exceptions needed internally. Yeah, I guess, but it's still fucking stupid. Like it's dumb. Do I know Python? Yes, a little bit. But nah, type ID is just like we'll see how it works when they add reflection into it. It might be more useful when they do that, but C++'s runtime type information is so bad that I have my own Python script to generate essentially what type ID is. Like it's so bad of a keyword that I have to write my own version of it to actually have it be useful. Type name. Type name is part of templates, so it's kind of up here as like one of these things that like you have to use, but it also feels a little bit janky in some of the situations where you have to use type name because it kind of feels like it arbitrarily gives you an error message and you're like, oh wait, yeah, okay, I have to use type name here. And it's like, okay. Is there any difference between type name and class? Type name is used to um, not. Oh, yeah, there is a difference in the template declaration because type name could be a class or an int. Um, although I don't know why you would ever want to do a template that could take a class or an int, or if there's any situation um, where that would be correct. But no, type name is used in um, situations where within a template you have like a type def within the template and you want to be able to say that this thing within this template is a type and not a variable, so you have to use it sometimes. It's yeah, disambiguate dependent names. It's one of the it's like you never remember that you need to use type name. You just write a piece of template code and then it gives you a compiler error somewhere and you're like, oh right, I have to put the word type name there for some reason. Like it's you have to use it. You can't get away with not using it. Um, and C++ has continually reduced the case, like with revisions of it, they've reduced the situations where you actually need to use type name. There's always some proposal in every version that's like, okay, we can get rid of the fact that you need to use type name here by doing some other thing. But like it was just a word that you paste somewhere to make it compile when it wouldn't compile before. Nobody remembers when you actually need to use it. Yeah, type name usage went up at concepts, I guess. Sure. I mean, yeah, it's definitely more useful than concepts currently. Const of val. I know what const expression does. I don't remember. I don't understand how this is different from const expression. Like I don't understand why they couldn't just use const expression in every situation where you would want to use const of val. Const expression, but really this time, yeah, true. Where did I put the other one that was like this constant? I'm just putting it here because it's stupid. Const expression. Uh, in theory, const expression should be here, but like Like in theory, it should be here. It like barely works though, so who knows? Consequential has a few problems, so they made a new one instead of fixing it. I'm just gonna put it down here because like it's just like they. I don't understand why they can't like make it properly work. Uh, a line of, um, a line of is like less useful than a line as, so it's going down here. Uh, Static assert. Um, I guess static assert kind of goes up here with like concept stuff because in theory it should make template error messages nicer, but like in practice it's also just going to be kind of annoying. It's a whatever. If it makes error messages in the standard template library like better, then sure, it'll be fine. I don't know why it has to be a keyword again. All right, inline. Inline should be like an F tier keyword, but it's going up a little bit. Um, because inline has a secondary use now, which it didn't have. When did it? When did it? It's a relatively recent one. Uh, yeah, this one right here. It, 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 I'll explain what I mean, but it should be an F tier because inline doesn't actually force the compiler to inline something. It just suggests the compiler to inline something, and that's generally not something that you actually want to do. Like in general, you want to let the compiler decide whether or not to inline something because it's going to make a better decision of it than you are. So in the best case scenario, inline does nothing, and in the worst case scenario, your code runs worse because you inline something that shouldn't have been inlined. So it should be an F tier because of the actively harmful about it, um, the actively harmful bit about it. But it's not because it has a secondary use, which is that, uh, and I don't remember when they added it, but you can use to take a static variable like if you do inline static, you don't actually have to define the variable in the C++ file. You can just leave it in the header file only. So it's like because of that, let me find something that has uh, like so you see the static unsigned int object counter right here. Normally you have to do this in the C++ file to actually get it, but since they've added inline, I believe you can do inline that and equals 0, and then I wouldn't actually need to have this line of code right here. Uh, like that, I believe that that's how you do that right now. I don't know why they make it so you have to use the inline word. I don't know why they can't just do that like you can do with other things. But the fact is, I did not mean to Bing fuck like click that and have Bing pop up. I don't know what the fuck. what? Why did it pop up Bing when I clicked that? So I don't know why. I'm not gonna change this because this is a kind of I don't trust making changes to that specific file right now. Um, but yeah, I don't like. It's weird that they make you use the word inline to do that. Like it feels like you shouldn't need to put the word inline there. Yeah, and but I also think that you need to use inline if you have a function declared in a header file across multiple compilation units. I think that it conflicts if you don't have them labeled as inline. Um, so that might be another situation where inline is useful, but in general, inline is a bad keyword because the it, it doesn't really do anything but make your code worse. Like there you go. All right, operate. I don't know if I should even rank these because like whatever. Like this is clearly the worst named one of them. I don't the bit and bit or And equal, like why not just have the word equal? Or like you don't need to use and equal. Like you could do equals, which why is equal? Why is EQ not a keyword? Like how are you gonna assign a variable without EQ being a like why is this such a partial list? Like okay, you can write code, but you can't do equal or a parenthesis. Like yeah, the underscores aren't consistent either. Well, it's probably because this is two symbols and this is one symbol, but this is also two symbols right here. This is like I don't know. I don't know why. Yeah, they got rid of digraphs in one of the recent versions, right? Like digraphs don't exist anymore. I'm pretty sure. Oh, trigraphs don't exist anymore. Removed in C++17. Yeah. So I don't know why these are like why they even exist. So I can't call them F tier because they're not actively harmful the way that most of these are. Um, register is not actively harmful, but register is absolutely pointless because it got deleted. But all right, register has to be the top of F tier because it's not actively harmful the way that these are. I guess no accept as well. No accept's not actively harmful the way throw is, but it's significantly tied to throw in a way that like the others aren't. Yeah, that seems about right. Yeah. All right. I believe that this is the definitive tier list of C++ keywords. It took 2 hours of discussion to figure it out, but I believe that this is correct. Uh, if you disagree with any of these, you're wrong. Take it to Twitter. Um, and I believe that that should be the end of the stream, but I'll take some questions if people want to ask some questions. Just download this so I can tweet it. Why did why did this logo end up here? Why did it get rid of these? You can ask me questions about anything programming related, opinions on languages or other things. Like I could talk about these right here or these right here for preprocessor. Define would be an S tier. Um, define would be like S tier. Include would be like C tier because honestly, fuck include files. Like they should fix that a while ago. Tell me how I feel about uh Lua. I kind of hate Lua. Like I like the idea of an embeddable, like a language that can be easily embedded in another language so that you can, hook stuff up and script with it. Like it's a very useful thing, but I hate Lua as a language so much. Like I would just really like if they could do like an embeddable version of Python instead. Because Python's much nicer than Lua. Or even JavaScript, or JavaScript. Like if they made an embeddable JavaScript that I could hook up functions in C to, that would also be much preferable to Lua. What do I think about upcoming languages like Jai, which would be John Blow's language, which I don't know if it actually is officially called Jai or not, but I do like uh, I do like some of the stuff he's doing in his language. I think that the ability to run compile time to run Jai code, compile time that outputs Jai code is a very useful feature that would be the main incentive of using his language. I think if you could do that in C++, I'd probably just use C++. Um, but you can't. C++ has decided that you're going to use template metaprogramming if you want to do anything in compile time, and that's every update of C++ just makes more bullshit for template metaprogramming than just making it be programming. Um, so who knows? We'll see. I I respect John Blow's opinions on programming. He's clearly a good programmer and knows what he's talking about. But I do disagree with him on a couple of things, and I fear that some of his personal opinions on programming are going to prevent Chai from being as good as it could be if he would embrace some other good parts of other modern languages, like coroutines. Like I think I mentioned asking. I think I asked him about coroutines a while ago. By like a while, I mean a couple years ago, and I think he had no experience using coroutines in any language, and so doesn't understand the benefit of a coroutine versus a thread. So who knows? Plus the general disdain for stuff like polymorphism is like, and various OOP stuff means that there's probably going to be like I don't remember I haven't seen the language recently, but I remember when he was first talking about polymorphism that he had it working with his compile time code generation stuff. And instead of it being a language level feature. And that kind of worries me just a little bit because like that should be polymorphism should be a language level feature. But we'll see. How do I use standard library stuff like standard vector? Yeah, I use standard vector all the time. Like I have my own. I have a couple of my own vector classes in my engine that I use for other situations, but for a list of dynamic objects, I use standard vector all the time. I have my own for. I mean, I could probably show you. Let's just zoom out to a nicer. I have container stuff. So I have pod vector, which is for things that are trivially copyable, so I can mem copy stuff around instead of having to use constructors or destructors. And then this also has a couple of extra features on it, like that vector doesn't have, like f pushback, which is fast pushback, which does not resize your container. So the way that you use f pushback as opposed to pushback is you size the container up to the maximum size that you want first, and then you can f pushback. Like you could resize, you could add 100 things to the container and then f pushback 100 times. It has some uses. Like that's one that I have. I have temporary, which doesn't use new or delete. It uses a temporary memory management thingy. And then I have the no copy vector, which is just a standard vector that cannot be copied, which I use in to enforce that I have to have something as a reference instead of copying it, which makes sure that I don't accidentally make copies of things that I'm not supposed to make copies of. How do you read and debug an error code when it's just things like register values and stack values? If I'm running here, it tells me where the code crashes, so I don't know when you only get a register value or a stack value. Basically, I have my own Flash runtime in my engine, right? Kinda. I load Flash graphics and I convert them to meshes. It's not really a runtime since it doesn't really run code that was written in Flash. It runs an extremely small subset of ActionScript 3 solely so that I can like get the name of a function that's being called, so I can hook stuff up, hook events up to custom functions. But you can't actually, it won't actually parse and run ActionScript code very like that much. Everything has to be coded in C++. I just use it for graphics. What's the benefit of coroutine versus thread? Thread is But coroutine doesn't run in a thread. Coroutine is like is for a resumable function. So you could run a function up to a point. Like the main thread that invokes the coroutine halts until the coroutine yields. And then you can choose to continue the execution of that coroutine from the main thread whenever you want. It's like it's not necessarily for parallel programming. It's resumable functions. Like you can partially execute a function and then you can return to that whenever you want later. Um, all on one thread instead of having it be on another thread. It's useful for stuff like in Unity does it for like scripting stuff where like you can have a coroutine yield for like 6 frames or whatever, and it will if you say yield like 6, wait for frame 6 or wait for second 6, it'll just 6 seconds later it'll come back, like the Unity's coroutine manager will resume that function. Like it's in case you want to handle that stuff yourself instead of the operating system doing it. But it's all on one thread, so you don't have to worry about like synchronization primitives or atomics or whatever. Ever had a look at Odin? Nope. Naughty Dog's talk on fibers, I guess. I don't know if coroutines and fibers are the same thing. Why the hate for boost? All right, hold on. I have this bookmarked. This is bookmarked under a thing called "Why Boost is Shitty." Click here to view the latest version. Yeah, design rationale. Let's just zoom in a little bit because I don't know how. So let's talk about why Boost is shitty by just reading this article from Boost.org. Like this is a source that wants to paint Boost in the best light possible. All right. Suppose you need a C++ program to calculate the distance between 2 points. You might define a struct. Struct my point double x comma y. Like this is the shitty way to define it. Like, you should. I don't like the comma operator in this situation. Just do double x double y on 2 separate lines. Whatever. It doesn't matter. Like I don't like they're saving a line here, but then they're wasting a line by putting the opening bracket on its own line. Whatever. And a function containing the algorithm double distance and constant reference. Yeah, I forget. Whatever. Double, square root of a dot x minus b dot. Standard Pythagorean theorem. Quite simple and it's usable, but not generic. Now, this is the correct way to do things. This is how you do a distance algorithm. Like there's no reason to do anything more complicated than this. For a library, it has to be designed way further. So, all right, just soak up this sentence right here because this is basically what the problem with Boost is. Boost is presenting this as incorrect and then saying for a library, it has to be designed way further. The design above can only be used for 2D points, for the struct my point and no other such struct in a Cartesian coordinate system. A generic library should be able to calculate the distance for any point, not just on the my point type, in more than 2 directions. I agree with these two. For other coordinate systems, example, over the Earth or on a sphere, I disagree with that. Between a point and a line or between other geometry combinations, again, I disagree with that. If you're having a distance function, you should probably be like, those should be separate functions. In a higher precision than double, sure, but that's kind of, when you template this up, that's going to happen anyway. Avoiding the square root, often we don't want to do that because it's relatively expensive, and for comparing distances, it's not necessary. Okay, I have a function called distance squared for that purpose. I don't want to. Why would you want all of this to be just distance? If I'm not getting the distance, why would I want it to be distance? Anyway, in the following sections, we will make the design step by step more generic. Using templates. The distance function can be changed to a template function. Sure, I mean they're gonna template double up with like a decal type later, like that's fine. This is sure you can do this. This makes distance better. And I agree with this particular function. Slightly better, but not much. Consider a C++ class where member variables are protected. Oh boy. Such a class does not allow you to access X and Y members directly. Oh man, we're getting there. Using traits. Uh, and then you need traits, and then blah blah blah. I'm like, okay, you've gone pretty far over the deep end, and you haven't even just done decal type, like decal type that in there, or I think you can do auto now. I think you can do auto distance to automatically have this be decal type, like whatever. Calling traits access my point zero get a now returns this or X coordinate. Nice, isn't it? Oh yeah, look at the scroll bar. We're here. We've got a ways to go. Nice, isn't it? All right. Dimension agnosticism. So now we could calculate the points in 2D of any structure. But what about 3D? And then there's boost static assert dimensions are like boost coordinate type. Like we assume double above. What if our points are integer? So now I'm not going to read it word for word, but like, all right, different geometries. Now, what if you want to define a different distance function that, like, you have to define the distance function to do this? So why on earth does boost now like you're already writing a new distance function for this? So why should boost? But like, whatever. Two solutions: SFI-8, which is again a stupid fucking C++ thing. Tag dispatching. So now this is what your distance function looks like now. Again, we're not even halfway down this article. Um, return dispatch distance type name tag G1 type like this. This reads like a parody. Like this reads like that like FizzBuzz Enterprise Edition kind of thing. It is returning to the tag meta function, and I guarantee you, you're not going to be able to like do any of these things where you expand the distance function properly without understanding how this shit is architected. Like, so all this shit they're doing is pointless because you're not going to understand how to write like the traits class that correctly makes your hyperbolic points distance function work right. Like you're just not going to fucking do that. Template type name tag blah 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 blah. Namespace dispatch. Namespace dispatch. Blah blah blah. Kernel revisited. I, it just degree or rate like why what how does distance care about degrees or radians? Strategy. Imagine having your distance function require a fucking thing trait called strategy. Like strategy distance. Like this is just point concepts, return type. Oh, and now it kind of gets down here, but like you could just use auto now because you can do that. Structured distance result type name. Like you can just use auto. Like this is unnecessary because C++ has a keyword called auto now, which it's had for like 10 years because C++11 is 10 years old. Axis order. Uh, in this design rationale, boost.geometry is step-by-step designed using tag dispatching, concept traits, and use the well-known distance function to show the design. Boost geometry is designed like described here, with more techniques as automatically reversing template arguments, tag casting, and reusing implementations of blah 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 blah. Anyway, that's why Boost sucks, and that's why I don't use Boost. I actually found like something that was funny was that when I was reading Wikipedia articles for various algorithms, somebody was writing C++ example code using Boost and advertising that you can use Boost for it. And this guy, I checked the guy's revision history on Wikipedia, and he only every one of his revisions was adding a Boost to C++ examples on Wikipedia, and they were all terrible and atrociously written examples. And I went and deleted all of them off of Wikipedia because really, like, the guy was using the guy who was editing that into Wikipedia was one of the guys who is like one of the Boost editors, like an actual contributor to Boost. Um, And no, I deleted all of those from Wikipedia because I don't think that your C++ example should require you to use Boost. Oh. I didn't bother writing examples myself. I leave that as an exercise to the user. All right, what was that? All right, what did somebody ask about Boost? All right, any more questions? If you want to see a game shipped by Boost creators, it would probably be pretty performant, but it would also take 4 days to compile, my opinion. And it would probably have 20 million lines of code, and basically be Pong. Like, what if you wanted your Pong to be in four-dimensional hyperbolic space? Well, you should be able to do that at compile time by writing the traits. Maybe that guy making that 4D game would find it useful to structure his code that way. I don't know. Yeah, parts of Boost have been standardized, so use the standardized. I refuse to use Boost. I will wait for them to be standardized before I use them. Ever tried mouseless code editing? No, I like my mouse. Like why would I want to not use my mouse? I can do shit like that with the mouse. Are you one of them Vim or Emacs people? Because I find those people weird. I don't know why you wouldn't want to use a more modern text editor. Visual Studio obviously has some issues with performance and crashing, but uh, it's modern, and like just the fact that I can hover over the word auto and just see what it is instantly is a big part of my workflow. What does component do in my engine? It is component is going to be roughly, I believe, this expands to. I believe it expands to this, but then it also has like a struct defined up here for some like meta programming bullshit. Struct blah. I believe that this is what component would derive to. So it's roughly, uh, derived component with boilerplate. It's roughly the same as doing character derives from component. But I could derive it from another class. Like I could derive it from a renderer if I wanted. But I'm not. It's just there's a lot of boilerplate that goes into this shit that does some shit that my engine needs. So yeah, instantly. Yeah, okay. Well, it's more instant than pretty much. It's more instant than VIM or Emacs, which will literally not do this ever. So, relatively speaking, yeah, it's about like 300 milliseconds delay. And this computer is 3 years old. So when I update and actually put like an AMD processor in a computer, it might actually be instant. Include files suck. Will they address any? Will modules fix that? I have no idea. I've looked at modules. I think the fact that you have to like export functions from modules will make them more annoying to use than like include files were. But and I have so much code that like uses weird template shit and defines that I don't know if they'll actually work properly with modules. So we'll see. I'm hopeful that it'll make at least standard library stuff better. Because right now I just gave in and started using pre-compiled headers, which do speed up my compilation significantly, even though they were kind of annoying to figure out how to use. Uh, Vulkan triangle with boost at only 13,945 lines of code. I think that's probably less lines of code than Vulkan. So I tried graphic tablet code editing. I don't have a graphic tablet. Do I use Visual Assist? No, I use uh I use VS Fora, which is nice. Color theme editor, which is why I have my color theme extend past the bound, like not just the text, but also the interface. Hide suggestion and outlining margins because it was annoying. And then I think that's about it. That's all I use, really. Tab sanity. VS Fora is for rainbow braces and for making control flow keywords be read. Rainbow braces are cool. Do I use separated threads for video and audio? For video, I mean, I think OpenGL uses a thread, but no, most everything is on one thread. Um, the data flow that you need to actually have video stuff like separated to another thread is kind of annoying, and my engine is not good at copying states, so I don't want to deal with synchronization when like moving things around. Uh, for audio, I do believe I'm using like my audio engine uses threads internally. I use F audio, so like audio is always going to be on a separate thread. Like I don't think you can possibly do audio on the main thread. All right, I don't really want to answer too many questions about my engine, but Vim definitely makes navigating around in text while editing faster. I mean, maybe if you know Vim, but I don't really know Vim or Emacs, so it would probably be me switching to Google. Like, how do I go to the next line in Vim? My code is so huge that I don't even know if that would even, if it would, like I have 300 something files of code. It's actually to the point where like I really like one of my main issues with like the Mugenics code base is that there's just so many files of code. Like if I'm trying to find like level.cpp or whatever, it's right there. But like if I'm trying to find, a specific file, I have to basically search for it now because there's just too many. Even though they are organized somewhat good, like I've got like 200 files for passive effects here. Control plus. Oh, you mean like Vim? Because it's not. I mean, there's this right here. Either way, it's getting a little bit large. I like having a good IDE. Also, Visual Studio's debugger is pretty great. I like my modern tools. Okay, I like having the red squiggly line when like I code something that's not gonna work right. Like if where would it be? Some like this right here. Like this is an error if I don't have the reference here because this returns a no copy back. So like I like just being like, oh right, okay, I gotta go do that, and then the red squiggly line goes away. Also, like having all these files organized properly in two different projects, engine and game, because this engine project is shared between like 10 other projects that I have. And if I change, the engine project is shared with the game project, like the solutions are different. Yeah, I like Visual Studio though. I like all the information you get on hover, mouse hover, and the debugger is good. All right, been talking for like almost 2.5 hours. Which new stuff am I using for Mugenics from C++20? So far, I think it's just concepts. I think I have in my engine, I think I use some concepts in some of my util code here. Yeah, so like numeric, which is a concept. If it's not a concept, it just defines it as type name. So some of my math code uses it just to make sure that I'm not using lerp on non-numeric types, basically. And that's the only thing that I've added from C++20, I think. I want to try, like, I would go do coroutines, but I had my engine coded. I had, like, the main battle system coded before they added coroutines, and it doesn't make sense to switch what I was using to using coroutines instead at this point. Yeah, exactly. It's a good tutorial for learning DirectX. I don't use DirectX, I use OpenGL. And if you're asking if you like, this is just something that is a general thing. I'm never going to be able to recommend tutorials for you. Like, this is, I'm so far past the point of needing to use tutorials to learn things that there's no way that I can recommend a tutorial. Like, all the tutorials that I used were 15 years ago for Flash games. Like, that's just how it is. I don't mean that like I'm not like trying to like humble brag like, oh, I'm just too advanced for tutorials. I just mean like if I need to know something about C++, I like look up the documentation and read it. Like, I don't follow tutorials for things. It's 15 years ago I would follow tutorials to learn the general basics of things, and those tutorials are irrelevant at this point because everything about those has been outdated and redone with modern versions of things. Uh, that is overridden saga was fun. Oh yeah, is overridden is nice. I'll like give context behind that. So I use it in exactly one place in my engine, and that is. Um, so you see all of these events right here, like earliest update, early update, update, late update, latest update, always update, early unlock, like all of these right here. Um, as I've started, like I've been splitting components up into more things. Should I zoom in? Yeah, I've been like doing more components on my objects. So in the end is nigh, characters and things would have like 3 or 4 components on them. In Mu, it's up to like a one object on screen is going to have like 20 or 30 components that make it, and having a shitload of components that don't even implement these callbacks starts to add up when you're trying to like loop through these callbacks. And if you're looping through update and calling update on every single component that exists in the scene, when 99% of those components don't even override update. So um, in my component boilerplate, every which is component uh derived component, like this right here checks is overridden for a specific function. So then in the actual scene itself, uh, when I want to call update on all of my components, it checks. Actually, it's not there. It's when I actually create a component. Like, the scene itself has a different list for like all the components that need to be updated, all the components that need to be late updated, all the components that need to be always updated, and then when a component is added to the scene, which that was split out into another file. Hold on. Scene template implementation. When a component is added into the scene, it checks to see if it overrides that specific function, and then it puts it in the function list. And this is using macros, enumerate all component events, just lists all the thing. Like, I like using this bullshit is code I never have to touch because it works, and I don't have to touch it. So I'm okay making that code be ugly and weird looking as long as what it does works. What are my thoughts on entity component systems? I don't quite get the point of them. I'm gonna be honest. My code is not entity. I don't like the fact that entity component system is a different thing from components and entities, as like the way that Unity did it before. Unity had entity component system, where you have an entity with a bunch of components on it that are kind of just individual objects that can communicate with each other. That I understand that. Like components that can communicate with each other but are somewhat independent objects. Um, that makes sense. That's how my engine's structured. It's a natural way to like split up responsibilities for things. Your renderer can be one component like that. That works fine for me. That's the correct way to do it. I don't like that I can't call it entity component system anymore, because entity component system means something entirely different now, and not like entirely different, but different enough that the Google results are different. Whereas entity component system is entity component system, each their own things, with the system being an important part there. Where like the system could be like, okay, a renderer is any object that has a transform and a model or whatever, like some type like a, and then it will pick all of the ones that have a transform and a model components, which are only have data, and the system will go through all of those and update them, as opposed to being like, each of my individual components can implement these functions. Like the only point where I like entity component system seems to be if you really really need like cache locality to matter for uh certain, like if you want something to be extremely performant on like thousands and thousands of game objects or whatever. But in my experience, um rendering is gonna completely dwarf anything you can possibly do on the CPU. So anything that optimizes the CPU side of things is just kind of dumb. Like, or not dumb, but generally unnecessary. Like, I don't need cutting the amount of components that update from 10,000 down to like 100 by doing that is overridden macro thing. Pretty good. Uh, Making your cache locality on things up, like anything that cuts off, like it's irrelevant. Like my CPU, even in Mu, like the things that take time is not the entity updating stuff. Especially not since I've updated it to only call update on the things that need to be updated. Like nothing I can do on the CPU side is gonna make any significant difference compared to optimizing rendering. Right. Just optimize rendering. My rendering's gonna take 4 milliseconds per frame or whatever. Uh, and my CPU is going to take 100 microseconds or whatever. It's not entirely true. There are a couple of things in Mu that do take a long time to do on the CPU, but it's not stuff that's done every frame. So, like, it's stuff like running the enemy AI, which does take a couple milliseconds in the worst case. Yeah, I don't understand ECS. I think that it seems like one of those things that doesn't actually have any benefits game logic wise and is mainly a performance optimization, but it's not a performance optimization on the side of a game where performance matters unless you're doing like Factorio, but Factorio doesn't even do ECS for their stuff, so it's not really necessary. Who knows? All right. If there are no more questions, I'm going to end the stream. I've been talking for a while. I need to like eat and drink water, and hopefully you enjoyed me ranking every C++ keyword though. All right. Bye. Thanks for watching.